Okay, 4.4, we talked about identity and inverse matrices. We're going to do some by hand, but for most parts, I taught you in class how to use a calculator and find the inverse of any matrix without having to work hard on it. The identity matrix for a 2 by 2 looks like 1, 0, 0, 1. Your main diagonal will be made by ones. The opposite diagonal will be made by zeros. The identity matrix for a 3 by 3 has the main diagonal 1, 1, 1. And if you remember, we talked about this when we did the 3 equations with 3 unknowns. You would get the identity matrix and then the solutions, and we said anytime that this column gets moved over there, you don't have a solution, right? This is just your identity matrix for a 3 by 3. You have this in your book, you find that. Also, you need to know that anytime you times a matrix with its inverse, you should get the identity, and that's how you check it if you do it by hand, which we won't eventually. We're going to learn how to do the inverse of a simple 2 by 2 matrix. We did this in class, right? And we said in order to find the inverse, you're going to go 1 over the determinant of your main matrix. Then you times this by DNA, your diagonal changes places. Your second diagonal stays the same but changes signs. How does this work? By hand first. This is my main matrix. I want to know what is its determinant. Well, it's 1 over 2 times 3, 6, minus 4, 2. I'm not even going to write this because it's 1 over the determinant. The determinant is small diagonal, 6, minus the other diagonal, 4, 2, times. And now I get to rewrite this as in 2 changes places with 3. 1 and 4 stays the same, but they change sign. And then remember how we times a, what did we call that? Just a number on everywhere. We just distribute it to each one of them. This becomes half times 2 gives me 1. Half times negative 1, negative 1 half. Half times negative 4, negative 2. And half times 3, it's 3 over 2. And we got this thing out of here, right? Now, do we want to check it? In order to check it, we will have to multiply with each other and get the identity matrix. We did not do that in class at all because we didn't need to do that. Now, how would we do this? Simply by using a calculator. So let's go ahead and go to second matrix. We're going to put this matrix in. This is a 2 by 2. We're going to go over to edit every single time. That's going to be your first step. Enter. I'm looking at 2 by 2. And now I get to put in by rows. 3, enter, 1, enter, 4, enter, 2, enter. And we're done. My matrix is done, right? So I'm going to go second, quit. And really what I'm looking for when I write inverse is a to the negative 1. That represents my inverse. That means, because inverses, we flip it. So I'm going to go second matrix. I'm going to say I want this matrix A, but I want it to the negative 1. You actually have a key for this. It goes like that, right? And you put negative 1. And then you hit enter. There it is. The problem is you have right now decimals, right? But we've learned how to do this. We go math. We want a fraction, right? Enter. What is enter? Enter. Enter. And here it is. Negative 1, negative 1 half, negative 2, and 3 over 2, right? So in order to write it as a fraction, all you have to do once you get that matrix, go math, enter, enter, and it gives it to you the right way. So it's very easy to find inverse matrices for any kind of matrix like that. Now, after this, we have learned about all kind of equations of how to solve stuff and find out the inverse of any matrix. How do we do it? How do we get there? Well, here it is. Let's say you have the matrix A that is 4, negative 1, negative 3, and 1. 4, negative 1, negative 3, and 1. Am I right? Yep. And I times this not by scalar, that's what the name is, scalar, but by a big X, which means that's another matrix. I times it by another matrix, and I get the following matrix. I get 8, negative 5, negative 6, and 3. And the key is like, how do I find out this matrix that I times it by this one to get those numbers, right? There's different ways to do this, but we're not going to worry about how do we look at it that way, because here's what we know. If I find out the inverse of this one, and I times it in both places, this becomes the identity matrix and it disappears. So what I need to do is find out what is the inverse of this matrix. We're going to come in here, we're going to go second matrix, go to edit. We already have it as a 2 by 2, right? So we hit enter, it's a 2 by 2. I'm going to go 4, -1, -3, 1, and I have my new matrix in. And I want to find out its inverse. So I'm going to go second quit. I'm going to go second matrix again. I'm going to select A. And remember, this is my key. I'm going to say, what is A to the -1? That's what I need to know. And my inverse matrix for this one is 1, 1, 3, 4. As soon as I found out of this, I'm going to say I'm going to times this with, is it right? Yes. 1, 1, 3, 4. But because I'm doing it on this side, I absolutely have to do it on this other side. 1, 1, 3, 4. Right? This and this, when you times the matrix by its inverse, it cancels these out because it gives you that identity matrix, right? Which really does not exist. So I end up with x equals this matrix times this matrix. Now there's two ways to do this. The long way is to put this in your calculator, times them, and you get the answer. The short way is to remember how you actually times matrices. It's not that bad. I go a times 1, 8, plus -5 times 3, -15. This gives me -7. A times, wait, 8 minus, is it a -12? Wait, this times this, this times this, this times this, this times this. -6 times 1, 6. 3 times -3. Oh, guys. I always forget orders. I'm so sorry about this. 8, -5, -6, and 3. I'm in a rush and I forget orders. Do you remember how we put this in front of this one? We have to put this one in front of this one also. 1, 1, 3, 4. We have to keep that order. 8, -5, -6, and 3. We timed it in the front. We have to times it in the front here. Remember how we said it always matters A times B and B times A don't equal each other? Okay, that goes away. X becomes, now we can do the math on it the right way. 1 times 8, 8, plus 1 times -6. This becomes a -2, right? 3 times 8, 24, plus 4 times -7. 24 plus -24 becomes a 0. 1 times 5, -5, plus 2 times 3, plus 1 times 3 gives me a -2, correct? -5 plus 3, -2. And then -15 plus 12, a -3. And my matrix that I'm looking for is -2, -2, 0, and 3. Now, the main key here that I completely forgot is remember, finding the inverse during the calculator is easy. When you put it in front of this one, remember your inverse also goes in front of this one. And then you can also just go, make second matrix, edit, make this matrix A, go back to edit, make this matrix B, and then just go A times B. You're going to get the exact same answer. It was faster for me. When you have a 2 by 2, it's very easy to do this by hand. It becomes way more complicated when you have a 3 by 3. So let's look what happens when we have a 3 by 3. They're wanting us to find the inverse of a matrix. And funny enough, because it's a 3 by 3, your book definitely tells you, use a graphing calculator. Here's my matrix. A is 1, -1, 0. 1, 0, -1, and then 6, -2, -3, 6, -2, -3. They want us to know what is A to the -1. Well, if you need to pause the video when you think you can do it and then repause it and see the answer or fast forward, second matrix, over to edit. This is a 3 by 3, right? 3 by 3, and I go 1, -1, 0, 1, 0, -1, 6, -2, -3. Second quit, second matrix. I go over to math. My first thing is my determinant. I hit enter. Then I go again, second matrix. Just tell it, yes, I want the determinant. No, don't listen to me. You go second matrix directly, you select your A. I don't need the determinant, and then I have that little key that says to the -1, and I hit enter. And there's my matrix. Let's see if we got the right thing that the book got. I'm going to look and see what we got. We did. -2, -3, 1. -2, -3, 1, 1, 1, because I'm cheating. -3, -4. -3, -2. Right? If I would times them together, if I decide to times them together, I will get the identity matrix. So this is how you get this done with a 3x3 matrix. Example 4 and example 5 are fun because it's kind of like a game, right? They go on top of it. They give you all of the letters, and all of them have a number assigned to them, and they want you to convert a message to row matrices, which means you can have one row, and a row matrix is going to be by 1 by 2. Let's see if we can do it. So, just as a thought process, or for you to remember, to convert the message to a number partitioned into a 1 by 2 uncoded row matrix. So if you want to make it from the words to the matrix, you're going to go 1 by 2 row matrices. How do we do this? Here's the thing. Well, GE. G is, if I look over there, 7, E is 5. I get 7, 5. What's my next matrix? T and blank. That blank counts for something, okay? T stands for 20. Blank gets a value of 0. H and E. H is 8. E I already used is 5. And then L and P are, L is 12 and P is 16. So we went from get help to row matrices, and we basically says use the list above to convert this to row matrices. We did it. Remember, they're going to have to be 1 by 2. And that's your example 4. Example 5, which I'm going to draw the line here and do 5, it says use the matrix 2, 1, no, 2, 3, -1 and -2. This is a matrix, a 2 by 2. To encode the message get help, you want to make it from here to numbers. How do we do this? Well, we already have the row matrices to do this. We're going to go 1 by 1 and times them by this and see what numbers we get. First of all, we're going to times 7 and 5 by this matrix. And I'm going to write the numbers down here as I get them. Again, you can do this using a calculator, but this is a lot faster doing it by hand. This is 7 times 2, 14, plus 5 times -1, 14 minus 5, I get a 9. 7 times 3, 21, minus 10, 11. I did my first part. I'm going to now move to the second matrix. I'm going to 20 and 0, and I'm going to multiply this little row matrix by this 2 by 2. 20 times 2, 40, plus 0, I get a 40. 20 times 3, 60, plus 0, I get a 60, right? I'm done with this one. I'm going to move over to 8 and 5. 16 minus 5, 11. 24 minus 10, 14. And I'm going to take the last one, which is a 12 and a 16, and write these numbers down. 24 minus 16, I get an 8. 36 minus 32, I get a 4. Okay? Basically, you go this times this plus this times this. Why do I get always a minus? Let's look at just this one. This becomes 24 plus -16, right? Or 24 minus 16 gives me 8. This becomes 36 plus -32, or just 36 minus 32 gives me a 4. Either way works. And now we went from the code that I got on the top, and we can send this as a code message. This was used a long time ago. I'm not sure it's still using today, the cryptograms. Maybe they are. I have no clue, but it comes from Greek apparently. But that's how we do it. Now, This is to encode messages. What about decoding messages? Okay, let me erase this. Let me get everything ready, and we're going to talk about decoding messages. I paused the video to get the board ready. We are on page 226. The last part of this is how do we decode? Really, how we decode this is you need a matrix first. You need to find its inverse. And then you see how they gave us, if you go on that page, a list of numbers. You transform those, again, into row matrices, right? By 2's. So I get negative 4, 3, negative 23, 12. I went 2 by 2, and I made them little matrices. And then we're going to times all of these by the inverse of this matrix. So let's find the inverse of that matrix first. I'm going to go to second matrix, over to edit. It's a 2 by 2, and it's a 3, negative 1, negative 2, 1. Second quit, second matrix. I want matrix of the negative 1. My inverse is 1, 1, 2, 3. 1, 1, 2, 3. And I'm going to times them all by this inverse, and I'm not going to write it next to it every single time because I'm going to go bananas. Okay, I'm going to do this by hand. If you need to do it differently or use a calculator, you can. It's up to you. Here we go. I'm going to times this by this. Negative 4 plus 6 gives me a 2, right? And then negative 4 plus 9 gives me a 5. That's my first matrix that I get. It's a 2, 5. Okay? Let's move to the next one. Negative 23 plus 24 gives me a 1. Negative 23 plus 36 gives me a 13. If I'm not crazy. I'm checking with the book always because I don't trust myself at all times. Negative 26 times 1, negative 26, plus 26, 0. Negative 26 plus 39 gives me a 13 again. Is 0 and 13? I sure hope so, yes. 15 minus 10 gives me 5. 15 minus 15, I get a 0. I know I keep putting commas there. They're not supposed to be in there, but I always tend to put it. Let's move to the next one. 31 minus 10, 21. 31 minus 15, 16. I don't trust myself. Negative 38 plus 38, 0. Negative 38 plus something that I know what that number is gives me 19. You would use a calculator. 19 times 3, 57. Negative 38 plus 57 gives me 19. Negative 21 plus 12, I get a 9. Negative 21 plus 36, I get a 15. I think so. I'm checking with the book. I'm always making sure I get this right. Answer, I did not get this right. Negative 21. Oh, plus 24. It becomes a 3. Sorry. 20 plus 0, 20. 20 plus 0, 20. And then the last one, 75 minus 50 gives me a 25. And then 75 minus 75 gives me a 0. And I got all of these row matrices. This is a long video just because of this. Well, we're going to have to go ahead and flip the page to where all of those letters are and transpose them. 2 is a B. 5 is an E. 1 is an A. 13 is M. 0 is space. 13 is an M. 5 is an E. Space. 21 is a U. 16 is a P. I should really copy the book at this point. Then I have a space again. S-C-O-T-T-Y space. Beam me up, Scotty. That's your message based on this. So you get all of those and you go back into the list of letters and you write it down. That's how you decode messages. You might have a lot of fun doing this. Please use your calculator to find any inverses you need to. Follow the rules in order to get this done. And happy homework!